Good evening, students. Today we are going to learn about the Rutherford model of an atom. We will focus over what was the Rutherford experiment, what was the experimental setup, then with this experimental setup, what was his observation and what he had concluded from the observation. And based on his observation, Rutherford given his own model, like earlier Thomson model, called as Rutherford atomic model. But still some limitation or some drawback remain with the Rutherford, which was not satisfying with the other general laws of physics or with the other common observations. So what are the limitations? Those things we will also learn. A student, what was this Rutherford experiment? So we are going to discuss with this Rutherford experiment today. Last day we had learned about Thomson atomic model, where the atom is considered as a positive sphere in which negative charge electrons are embedded or pudded into it, so that these electrons can be removed and the body can be charged. So this observation of electron or discovery of electron was done by the Rutherford through his cathode ray experiment. Now, with this discovery of electron, the Thomson had also given his model. This was the model. But this model was not satisfying the various observations made by the other scientists. Another drawback of this Rutherford model was, another drawback of this Thomson model was how these electrons are distributed inside the positive sphere. It was not given. So to understand the distribution of electrons inside this atom, Rutherford carried an experiment. The basic purpose of Rutherford was to know how the electrons are present inside the positive sphere. But the observation made by Rutherford was entirely unexpected. As a result, he had given entirely different kind of model than the Thomson model. So what is that? Those we are going to learn today. So a student, let us start with the Rutherford experimental setup. So what Rutherford has taken for the experiment and what he had concluded. So right, Rutherford experimental setup. Rutherford had taken positively charged helium nuclei called as alpha particle, and the other one very thin gold foil. He bombarded the alpha particle over the gold foil and noted the observation. Okay, so in his experimental setup, the very first thing is, this is also called as bombardment of alpha particle over the gold foil. Why gold was taken? Those things we will also learn. A student, so other name of this Rutherford model is also called as alpha particle scattering experiment or alpha particle bombardment. So in his experiment or in his setup, the purpose was to bombard a very thin sheet or a very thin foil of gold, which was just 5 to 10 atom thicker by the alpha particle. So the setup was minted for bombardment of alpha particles over very thin gold foil. So two new term here we are getting. One is called as alpha particle, another is called as gold foil. So what is this alpha particle? Let us understand this first. Then we will understand what is this gold foil and why gold foil was taken. Why only gold was taken? Why not iron or other element? If in place of gold iron is taken, then what will be the result? Bombardment means hitting or throwing. Okay, it is just throwing over or hitting, just throw something. Alpha particle is 2-unit positively charged helium nuclei. Students, we have learned helium is one of the element. If you are taking one atom of helium and from that if you are removing the 2 electrons, it becomes positively charged. Means helium is being rubbed or helium is converted into charged particle. It is found that helium can lose their 2 electrons because helium have 2 electrons. So on losing their 2 electrons, it become positively charged, 2-unit positively charged. Okay, so this helium with 2-unit positive charge is called as alpha particle. A student, how is the structure of atom? With that we can understand this alpha particle very easily, but those things we will understand after the Bohr model. Here we have to just understand helium is a atom or helium as an element. From that element 2 electrons are removed, then only their positive charge proton and neutron remain inside it. Then that positively charged particle is called as helium nuclei. This helium nuclei is also called as alpha particle. Okay, so it represents He2 plus is nothing but it is helium nucleus. So this helium nucleus is called as, is given a specific name called as alpha particle. So this is our alpha particle. So what is this, a student? For this, let us take one figure, a small figure to understand this. A student, this is the setup. For this setup we will come later, but right now we have to just understand this much part. Students, just understand this. This is representation of alpha particle, where the yellow ball represent proton and this red ball represent neutron, and collectively they are present at the center of an atom that center of atom called nucleus. This nucleus for helium is called as alpha particle. Students, we will learn in the next part of this chapter that say any atom is there, it always consists of a central region and outer region. This central region contains proton and neutron, and this outer region contain electrons. This is the Bohr model. This we will learn in next section. Number of proton which is inside this nucleus, means this part is called as nucleus. This one is our nucleus. So the central region contains proton. Proton are positive charged particle, what we had discussed yesterday, and electrons are negative charged particle. So these protons and electrons are always present in equal numbers so that the atom is neutral. But if these electrons are only removed, like even from the Thomson model, we may also consider Thomson model. From the Thomson model itself, if the two electrons are removed, then whatever the positive sphere that will left, that will represent the helium nuclei. This is called as alpha particle. But with the Rutherford model, which is more advanced and well acceptable model, electrons are revolving around the center region, center nucleus. So when this electron is removed, the central nucleus is left. That central nucleus is called as alpha particle. Okay. So this, for this helium contain 2 proton and 2 neutron. Also it have 2 electrons. So 2 electrons are now removed. What is left is 2 proton and 2 neutron, which is in this central region. 2 electrons, they are revolving outside the center region called nucleus. So it is for helium. A student, if you are considering the lithium, beryllium or boron or any other thing, only this number of proton and electron changes. How much proton? Whatever the serial number that we have learned in our last chapter, it will be that one. Say if you are considering the lithium, it will contain 3 proton. Number of neutron will vary. It contains the 4 neutron and 3 electrons also. This model we will learn in our next section. But here we have to understand alpha particle is nothing but alpha particle is a charged particle which contain 2 unit positive charge plus 2 unit charge. So 2 unit charge. What is 1 unit? 1 unit that is present on 1 proton. But likewise, here 2 protons are there. So 2 unit charge is here. And mass in term of AMU, 4 unit. What was for the helium? The mass number was 4U. The same mass, 4U. 2 unit positive charge, but 4 unit mass. Such a particle is called as alpha particle. It is represented here. Means this particle entirely, means collectively, this one is representing 1 particle. Okay, students. But inside this particle, there are subatomic particles. The subatomic particles are 2 positive charge particles. These 2 positive charge particles are 2 protons, which is shown here in the yellow ball. So these are 2 protons. And protons we had learned carry 1 unit positive charge. So this implies it carries 2 unit positive charge. Means 2 unit charge you may write. And 1 unit is how much, student? We had learned yesterday. 1 unit contain 1.6 into 10 to the power 19 coulomb. Okay, it is like 2 into 1.6 into 10 to the power minus 19 coulomb. So in terms of coulomb it is this one, but rather than writing this bigger number, we are calling this as a unit. Okay, student, but in exact number it is 2 multiplied by 1.6 into 10 to the power minus 19 coulomb. It is this one. And whatever this red ball or red subatomic particle you are observing, these are neutrons. What is this neutron? This we will learn later. It was discovered in 1932 by James Chadwick. It do not carry any charge. It only have mass of 1 U. So no charge. This we will learn later. But since it is 2 in number, so it have 1 U each mass. So this way we are observing neutron is of the 2U mass and proton also have 2U because each proton carries 1 U. So it also have total 2U mass. So the total mass of this alpha particle is due to mass of 2 proton plus mass of 2 neutron. So and since the mass of proton and neutron are 1 U each, therefore directly we can substitute 2U and 2U. So it is like 2 into 1U plus 2 into 1U. It becomes collectively 4U. And the charge on this alpha particle, it is important, student, it is asked. Okay, and the charge on alpha particle on this is denoted like this. Alpha particles means one particle we have to take, not particles. So the charge is because of the positive charge proton. So charge carried by two protons. So it is 2 into 1 unit. So total 2 unit positive charge. 2 unit positive charge. Therefore, alpha particle is denoted like this: helium with 2 unit positive charge. It is the denotation of alpha particle. Whether you write like this or this itself in short form denoted as alpha particle. Okay, student? So it is this one. So alpha particle simply means helium nuclei. Helium is the element whose atomic number is 2 and mass number is 4. So when the electron is removed from that helium atom, it becomes positive charge nucleus only. That positive charge nucleus of the helium is called as alpha particle. So this thing we have to keep in mind. Alpha particle is nothing but it is helium nuclei. Okay, so whether helium nuclei or like this one, and in short form this alpha particle is denoted as alpha particle.
Sir,
Yes, tell me.
sir, alpha particle can be different elements also.
Alpha particle is not an element in itself, but it is the helium only. Okay, student, the helium nuclei is called as alpha particle. That's why I have written this is not an element, but if the helium is losing is 2 electrons, means this is the helium molecule, helium atom I have drawn. So when this helium atom loses these 2 electrons, means these 2 electrons are removed from this atom, what left is the only 2 protons and 2 neutrons. So these 2 protons and 2 neutrons are represented here. 2 protons by yellow ball with positive charge, 2 neutrons, the neutral one, by red ball. Okay, so only this helium nuclei is called as alpha particle. Okay, student, so do not get confused that alpha particle is an element. No, helium nuclei or double charge helium atom is called as alpha particle. So alpha particle simply means double charge helium ion. Yes, tell me.
Where only helium can be alpha particle.
Yes, only and only helium nuclei can be alpha particle. So that we have to keep in mind. Okay, no other element or atom can be called as alpha particle. Though this alpha particle may be, you will learn in higher ed standard that alpha particle may be produced by various nuclear reaction during radioactivity. When the nucleus undergoes disintegration or decay, it produces the alpha particle. But what is that alpha particle? Alpha particle simply means like helium nuclei, means that contain 2 unit positive charge and 2 neutron. So keep in mind. So alpha particle, if you have died, please write. So let me write here. Many times it is asked. So alpha particle is double charge positive charge helium atom or double positive charge helium atom. What is left is only helium nuclei or nucleus. Okay, so helium nucleus is called as alpha particle. So alpha particle means identity same as helium. Okay, student, if you are taking the lithium, beryllium and charging it, you cannot call that as an alpha particle, though they are also the charged particle. Like sodium was forming Na plus, that was also the charged one, but that is not the alpha particle. So student, this alpha particle, this was the one thing he had taken, and this alpha particle was then thrown over a thin sheet of gold. That thin sheet of gold is called as gold foil. So it is the very thin sheet of gold. This is why this was taken, because gold is highly malleable and it can give the thinnest sheet. So very thin sheet of gold. The thickness of this sheet was just 5 to 10 atom thicker. 5 to 10 atom thicker. This much thin this sheet was. Like your paper sheet, paper, it appears have some thickness, but this gold can be so beaten and flattened that very fine or very thin sheet can be obtained. That thin sheet was called as gold foil. Okay, student, it was this one. Now, this alpha particle was thrown over the gold foil. So how it was thrown? It is this one. Student, you can see here. So the gold foil is represented by just a few atoms. Okay, I have just drawn here only one, but it may be more than one also. Like in your book, 3 or 4 atoms are drawn, but I have just taken only one for your understanding. So student, more if you want to get, you may get like this. This is the other figure that we may consider. So you can understand here only this much means this much or this portion is representing the gold foil. This is our gold foil. So gold foil that contain very few number of atoms in their thickness, means from one side to another side the thickness is very less. What he had done, Rutherford took the alpha particles. So these are the alpha particles denoted by alpha. So this is the path of alpha particle. So he bombarded over this thin gold foil. Means he took the gold foil like this. This you may understand, very thin. So I am drawing it vertically like this. Then the alpha particle, he thrown it over it. Okay. Then he observed what is going to happen. But students, these alpha particles are not visible to our naked eyes because atoms are not visible, though the gold foil is visible. So to see whether this alpha particle is being crossed and gone to the other side, or it have rebounded back, or in which direction it have gone. So these are the various possibilities. So where this alpha particle have gone, to understand that, since this alpha particle is not visible, so a screen was placed around this foil. Are you getting? So this was the screen. So another screen was placed. This screen was to understand where this alpha particle have gone. How this screen can detect? So this screen can detect by placing a scintillating material or coating in the inner side of this screen. You might have seen that when the light is falling on a photo film, then the impact is produced over the film and that is visible. In the similar fashion, the inner portion of this is coated with another material, fluorescent material called zinc sulfate. So zinc sulfate was coated on the inner side of this screen. And when this alpha particle, let us consider this alpha particle is going to hit here. So while this alpha particle will hit this portion, then here the light will be generated. So the light is generated from only those portions where this particle is hitting it. Otherwise, no light will be generated in other region. Are you getting? So with this way, where the alpha particle have gone, that can be detected. Therefore, this setup was made. So this light is generated. So you may write light generated like you are observing during the rainy days, after thundering, the lighting is produced in a sky. In the similar fashion, so where this lighting is produced, when the two clouds are colliding at that position only. In the similar fashion, when the alpha particle is hitting this screen, ZNS screen, which is done in circular fashion, then only light is generated. When alpha particle hits the ZNS screen. So this is ZNS screen. Okay, it was this one. So considering all these things, all these equipment or all these contents were clubbed together, and the setup made was this one. See how is this setup, student? Now I hope it is clear to you people that he had taken the alpha particle. Now say alpha particle cannot be taken in our hand and thrown over another seat because it is not visible. So an experimental setup was made. So for that, this alpha particle is generated through the alpha particle gun. Okay, those things will learn in higher standard, or through a source simply, which is placed inside a box, so that this alpha particle cannot move randomly as it wishes. Therefore, the source of alpha particle, see students here, the source of alpha particle is placed inside a box. This is your lead box where this source can be kept. So this is our lead box to keep the alpha particle stored. Okay, student? Then front of this another plate, the same lead plate was taken. What was the purpose for that? So inside this lead plate, you are observing there is a hole. Okay, so it is the hole in the lead plate. This hole allows only a very thin beam of alpha particle to stuck over the gold foil. Here this yellow one is representing our gold foil. Are you getting? And this outer boundary, it is representing photolithic plate. It have internal coating of zinc sulfate. So when the alpha particle hits, only at those positions you are getting these lights are produced. Getting? So this way this setup was made ready so that he can observe what is the direction of alpha particle when it hits this gold foil. A student, let us consider only one alpha particle. So if we consider only one alpha particle which is coming from here, it is going to move here, pass through this hole, and it will stuck somewhere here. After reaching here, there were various possibilities or various observations. One was, in most of the cases it was observed it is passing straight and hitting this region in front of it. Okay, student? But in few cases it was observed that some of them were deviated and hitting just sidewise, not just in front of this gold foil. And very few were even returning back. Getting? A student, the lead plate have another importance, that the lead plate with a small hole confirms that only few or a specific alpha particle have crossed, and after crossing it have hit this gold foil. Means direct alpha particle is not hitting any of this photographic plate or zinc sulfate screen, so that light is produced. So confirming that only the reflected or past alpha particle is hitting this photolithic plate, this lead plate with a single hole was used. Okay, a student, collectively this part is called as gun or alpha particle gun. Alpha particle gun means while the alpha particle is pushed, there is certain mechanism. This is basically a cyclotron, you will learn in higher standard. So through that cyclotron, the charge is accelerated and it is pushed or it is thrown over this gold foil. So this method of bombarding or throwing is called as bombardment. This way the bombardment of alpha particle was done over the gold foil. And from this, the various observations the Rutherford have noted can be understood now. Okay, student? So it was all about our setup. Now let us understand what was the observations, those things. Students, the same thing is also kept here. So let me rewrite something here. So in this case, here we are observing up to this much region is forming the, so this much setup is used for bombarding alpha particle over the, which one? Gold foil. This region you are getting, this is our gold foil. Okay, the yellow one is our gold foil. Then considering the individual alpha particle which is moving and drawn here is with the yellow line, the observations were noted. It was observed that most of them are passing as it is and hitting the region in front of it. It is the region in front of it where maximum, in this region, maximum light or a spot or a spark or light was produced. When maximum light was observed in this region, that confirms that most of the alpha particle have crossed this gold foil and hit this region. That is the one thing. Then the next observation was few of them or some of them are hitting this other region, means in this region. But as we move away from the center part, the number of light produced, called scintillation or lighting, is reduced. And it was observed that very few, it is just closer to this one, means it is, there is just, means this screen is just nearly touching each other, only a certain gap is there. So very few, very few were just returning back and hitting this region also. Okay, so here in this region, very few, very few. You may consider it is 1 out of 10 to the power 5. Okay, means 1 out of the 1 lakh alpha particle was just returning. Maximum was just in front of it. Some of them were get deviated, means after hitting it have not passed straight, but these are the deviated by some angle, So these were also lesser as we move away from the central or the front screen. Get it? So it was this one. So this same thing is drawn in your book only with this setup. Student, in simplified form, it is drawn like this. Here we are observing that the alpha particle gold foil, these two are drawn in this. The gold foil is drawn just by taking few atoms. Okay, atoms of gold foil. Here you are observing this. These are the few atoms of gold foil. These atoms of gold foil, only few are taken. Why? Because the gold was made into very thin sheet. The thickness of that sheet was just 5 to 10 atom. Means though it was broader, but the thickness was just 5 to 10. Just, or even it was 2 to 5 to some places. It was just one atom was touching another. It was so thin that you can imagine it was even thinner than your hair. Okay, so that's why for this experiment only 1 or 2 atom is shown. See, in this figure I have just taken one of the atom, then it is bombarded by alpha particles. So alpha particles are shown here. It is our alpha particle. So it is thrown over it, means the continuously alpha particle was thrown over certain region or certain area of the gold foil. So while throwing over a smaller area, it was observed that most of them are crossing, and in front of this you are getting that there is a screen which can detect where these alpha particle have crossed or not, or where it have gone. Okay, this was the screen. The screen is shown here. Okay, it is this one. So in this figure or in your book, the screen is not shown, but it is very important. Then it was, so it is concluded that most of these alpha particle are crossing as it is. Now here you are observing this particle, this particle, these particles are crossing, and few were get deviated with a smaller angle. Here you are getting, so these have just passed. So you may write here passed without deviation. Means most of them have passed without deviation. These are the few deviated with certain angle, and this number of deviated particles was further reduced if the angle of deviation is increased. So this was shown in this one. You are getting? So in this region it is maximum, and as we move away, the number of alpha particle making the light over this screen is decreasing, and very few, means 1 out of the 10,000 or even lakhs was just returning back. The last observation was, see, observe this ray. So this is this one which is hitting just at the center of this atom and just almost returning back. It was the very few, means just 1 out of the 10,000 or even lakh was observed to be returning back. So from these 3 important observations, one was most of the alpha particles were crossing, another was few were deviated by certain angle from 0 to 90 degree, means it is 0, and here up to here it is 90 degree, and very few were deflected more than 90 degree, and very few were returning back while it was hitting the center. From this he concluded that these alpha particle are crossing. It means this alpha particle is not facing the presence of this atom, means the atom is either empty here. You can understand like this. if you are throwing a small tennis ball over a large mess, then what you will observe? Most of the time it will pass. But once this ball hits the wire of the mesh at that time, it may be passed with some deviation, or if the wire is this much and ball is directly hitting here, in this case it may return backward. But even the wire, the ball is hitting on the side of the wire, by certain angle it get deviated and it will move like this. So this way the structure or the nature of atom or nature of this gold foil can be predicted. Based on these three observations, Rutherford concluded that most of the spaces are empty. That's why these alpha particles are able to cross and pass to the other side. Okay, student? Very few are deviated. It may see our alpha particle is positive charge particle, and it get deviated means the nucleus also have positive charge particle. That's why they have scattered, because it is positive, nucleus is positive, therefore there will be a repulsion and it will move like this. And very few were returning. It means what? Entire mass or a very dense region is present at the center of that atom, so that if the alpha particle, which itself is the nucleus of helium or a very dense particle, have returned back. So these were the important three conclusions from this experiment. Okay, students? So these things we are going to write now. So it was all about, so this alpha particle, what was this alpha particle? This is representing this, and whatever this gold foil we are considering, this gold foil is representing this part. Okay, student, it is this. So it is all about. In your book, only this structure is shown. Here we are getting that deflected alpha particle, which was almost returning. Some of them were deflected with certain angle, but most of them are passing. So these were the three important observation, and based on them certain conclusion was made. Okay, student? So let us write it quickly. What was the observation of Rutherford and what was the conclusion? Any doubt to any student? Then they may ask, otherwise I will go for writing. Student, so write. I am writing both together. Observation and conclusion of Rutherford experiment. So what was the observation done from that experiment? So you may write, on bombarding the thin foil of gold by alpha particle, I'm not able to write, students. Alpha particles on bombarding the thin foil of gold by alpha particles following observations were Noted. And after these observations, certain conclusion was drawn. Noted. And these conclusions were drawn. Means these conclusions were noted. You may write like that way also. So what were the observations? I will write here, and from that observation, what was the conclusion, that I will write in parallel to that. From this, what will be the conclusion? So I will write side by side so that we can understand. The first observation was, the very first observation was, most of the alpha particle was crossing without deviation. So you may write, most of the alpha particles were crossing gold foil. Crossing gold foil means, you may write in short, passed without any deviation, without deviations. So most of the alpha particle were crossing the gold foil. So even without deviation or with a smaller deviation, a smaller or little deviation. This was his first observation. So most of the alpha particle are crossing. What does it mean? It means that there is nothing. That's why the alpha particle have crossed. Like I had given you the analogy. Consider there is a wire mesh which is having large holes. Okay? Larger than the stone you want to throw over it. So if the stone size is very small and there are large number of holes in the mesh whose size is bigger than the size of a stone, then a stone will pass as it is. So this was the conclusion. Most of the alpha particles were crossing gold foil. This implies most of the space inside the atom is empty. That's why they are not offering any resistance or not stopping it. So this implies most of the space inside the atom is empty. It was the very first one. Now let us come to this second one. Yes, from this he concluded that the outer particle of the outer part of the atom is hollow. It's based on the experiment carried out by Rutherford. Following were the observations. He observed that most of the alpha particle were crossing. Most of the alpha particle were crossing. It means the alpha particle were not experience any resistance or any opposition. It means most of the space in an atom is empty. That was the first conclusion. The next, value of the alpha particle were deflecting. This deflection was varying from 0 degree to 90 degree. As we move from 0 degree to 90 degree means increasing the angle of deflection, the number of deflected particle was also decreasing. So this deflection indicates the repulsion between the alpha particle while it is approaching the positive charge present in atom. Okay, means what? You are knowing that two positive charges always try to repel each other. Since the alpha particle we have taken is doubly charged or doubly positive charge, and the atom itself have some positive charge. It was proved by the earlier experiment of E. Goldstein. So considering the repulsion between the positive charge alpha particle and proton present inside the atom, it was concluded that when the alpha particle is approaching the positive charge proton, because of repulsion it starts deflecting. Therefore, considering the observation 1 with observation 2, it was concluded that since most of the alpha particles are passing, but some of them are deflecting, it means the positive charge present in an atom is occupying very lesser space. So this lesser space is also very denser one. This is concluded from the third observation that we are going to write. And this denser mass or the very small volume inside the atom, which gives maximum deviation, is called as nucleus. So this way the concept of nucleus was given. So second observation, very few of the alpha particles were deflected. So this deflection is due to repulsion between the positive charge alpha particle and the proton, which is also positive, inside the gold foil. So from this, it was concluded that this positive charge inside the atom is present in very little space. It was the second observation. The third observation was very few, means even 1 out of the 10,000 was returning back. This indicates this alpha particle have hit the center point where entire mass and charge is present, so that it have rebounded back. Okay, so write that third observation, very few alpha particle, 1 in the 10,000 or even 1 lakh we may consider, were rebounded on hitting the gold foil. So right, a very few of alpha particle in bracket you may write 1 out of 1 lakh. 1 out of 1 lakh. That is 1 out of 10 to the power 5. So just you can understand how lesser is the chance of returning. So 1 out of 10 to the power 5 was completely rebounding back, was completely reflecting or rebounding, means coming back. Reflected back on hitting the gold foil. Hitting the gold foil. A student, here we are observing just 1 out of 1 lakh, means 10 to the power 5. It means return or reflecting back is possible only if it is hitting a heavy mass which is present in very small region. That region was called as nucleus. So this indicates a very or a highly dense, a very dense region region or area or volume rather, you may write, inside the atom which occupies very lesser space, which occupies very lesser space and contain, since it is very dense, means very heavy, and contain entire mass of the atom Okay, this region was called as nucleus by the Rutherford. This region, so this region was inside the atom. So this region inside the atom was called as nucleus. So student, this way nucleus was a term given by the Rutherford. So this way Rutherford discovered nucleus inside an atom. So what was his model? That we can write based on these three conclusions. So that we are going to write now. So the model proposed by the Rutherford. A student, from this we can say that the center region or the denser mass which is present inside the atom can be represented like that. If we consider this is the atom, okay, entire volume occupied by the atom, then inside this atom means at the center itself. Why center? Because the other atom was placed here and it was observed that in between there was no deflection. So that's why it was concluded that this highly dense region is at the center. So this center have very high mass or high density. So this is the denser region. So this denser region was called as nucleus. And these are the empty space of atom. So this is the outer boundary of atom. This is the drawn is the outer boundary of atom. What will be the size? A student, the size of this denser region called nucleus will be how much? Here it is observed that 1 out of 10 to the power 5. Means this region is 10 to the power means 1 by 10 to the power 5 times smaller than entire volume of atom. Means the entire volume is, means this volume is our 10 to the power 5. Then this region, the center region will be 1 only. Okay, students. So this was the conclusion, and based on this conclusion, Rutherford had given his own model called as Rutherford model. So that Rutherford model we are going to write now. Okay. So this nucleus size is, so this is the size of nucleus with respect to atom. Means if this entire atom size is say x, then x have to be divided by 10 to the power 5. That will give us this nucleus. Are you getting? It is this way. It's simply. Means this entire volume is X, then this volume of this nucleus will be our X by 10 to the power 5. Get it? So this way it was proposed that the atom itself is very small, but is still smaller than that. Inside that there is a nucleus. So if we consider the entire size of this atom, how a sphere is defined? By considering its radius. So you may consider the atomic radii. So this is called as atomic radii. Atomic radius means what is the radius of this sphere? That one. Then from the center to this much portion only, it will be upper nucleus radius. So nuclear or nucleus radius. So whatever the size, the same ratio will be also for the radius. So here we are observing that this atomic radius also starts from the center of this nucleus going to the outer one. It is this one. So he proposed that this atomic radius is very small, and it is around, we had already learned, it is of the order of angstrom, 10 to the power minus 10 meter, of that much size. So what will be the nuclear radius? So nuclear radius will be even 10 to the whatever the size of atom or radius of atom, that is still have to be divided by 10 to the power 5. It become how much? It become 10 to the power minus of 15 meter. So this 10 to the power minus 15 is called as femto, and 10 to the power minus 10 is called as angstrom. So this way the nucleus is very small region inside the atom, and this Rutherford proposed the existence, or the Rutherford model gives the discovery of nucleus. He also proposed this nucleus contain both proton and neutron. Basically, student, this neutron was not discovered at the time of Rutherford. So Rutherford didn't focus about the neutron, because the Rutherford carried this experiment in 1907, but the neutron was discovered in 1932. So he told that this nuclear radii or this nucleus contain the proton, which is very heavy mass, and this outer region means this region contain electron. Then how this electron is present? He told that these electrons are revolving around it. Okay, so this was the model proposed by Rutherford. So nucleus of an atom is very small as compared to total size. So this is written here in this order. So considering the size of atom, we are observing that nuclear size is 10 to the power 5 times smaller than that of the atom. Okay, so that was the important observations. Now considering these observations, what were the model proposed? So write, a student, Rutherford model of atom. Model of atom based on his observations. So this was based on his alpha particle scattering experiment or alpha particle bombardment experiment. Based on his alpha particle, so what they are deviated, that is also called as scattered. Alpha particle scattering experiment. Means whatever the setup and the conclusion that we have written. So based on his conclusion from right here at the term conclusion from the alpha particle scattering experiment. So his first proposition or his first point was that there is positively charged center in an atom called nucleus. There is a positively charged center in an atom. This positively charged center in an atom is called as nucleus. So this way, this model is also called as nuclear model of an atom. So it was nuclear. This nucleus also called as nuclear model of an atom. Other thing is, what was his model? His model is also called as nuclear model. So whether nuclear model or Rutherford model mean the same thing. The other thing was he discovered the nucleus. He discovered nucleus, which is very dense and very smaller in size, present at the center of the atom. Nucleus of an atom means each atom contains nucleus. This nucleus is very smaller in size, compared to the atom, or with respect to atom size. The size already we had written. So size of nucleus is how much, student?
Ten to the power minus 15.
So whatever the size of atom, that size of atom, you have to divide this by 10 to the power 5, or you have to divide it by, after 1 there is 50. So it was this one. So it is very small with compared to the size of atom. Another, since most of the reflected alpha particle was just turning back, means it contained most of the mass. It contained almost entire mass of atom. The atom. It was the second one. Entire mass, that is, it is most denser part of an atom. What is the denser and most mass containing part of atom? It is the nucleus. So this way, the discovery of nucleus occurred, and it was given by the Rutherford. Okay, students. So this thing we have to keep in mind: nuclear model or nucleus. It was the first thing. The next was regarding the electron. The electrons are present in the empty region of the nucleus. So write down second observation, second point of this model. The electrons are revolving around this nucleus. Around this nucleus. In well-defined orbit. In circular orbit. Okay, it was this one. Means what? Considering the two, it can be understood if this is the entire atom, then it contains this center region called nucleus. So this is the nucleus. So this nucleus, it contains proton, and this proton gives the mass of this atom, and whatever the extra region present here, means in this region there are certain circular path. On this circular path the electrons moves. Okay, student. So this was the model. On this electrons moves. Inside this nucleus there is proton, so let me denote it by P, and the electron. So write this as the electron. Electrons outside nucleus and revolve in circular path. This circular path was called as orbit. Okay, student. So I have just taken or drawn one electron, but there may be more than one electron. Means all the electrons are revolving in this region. Okay, so these are the space for electrons. Getting? These are the space for electrons. So electrons can revolve in these spaces. So these are the space for electrons. This way the model was completed. Getting a student? So yellow region may be written as these are the space or empty space for electrons. These are empty space. These empty space contain electrons. Okay, and these electrons are moving on circular path. So it is a representation of that circular path. Okay, student, I have just drawn one or two. The third conclusion was regarding the characteristic of this nucleus. The size of nucleus is very, very small as compared to size of atom. That was also proposed. Size of nucleus is very, very small compared to size of atom. It was this one. So these were the three observations or the three key feature of the Rutherford model. The first was propose the nuclear model, the region outside the nucleus but inside the atom was for the electron, and the size of the nucleus is very small. I had already discussed here. How is the size? Very small size. So size is 10 to the power 5 times smaller than that of the atom. Okay, it is this one. So it was this one. Then what was the drawback? Students, drawback is also important. Drawback or limitation of Rutherford model. Students, it was proven in physics earlier by the Faraday and other during the middle of 19th century that if there is any charge particle, say positive charge particle, okay, and around this if any other charge particle, whether positive or negative, if this is other charge particle, this is one charge particle, if it is revolving around this, then this charge particle always radiates their energy. Means the energy of this moving charge particle will decrease. When the energy is decreased, it means the path will not return back, but this path will try to decrease its radius, and lastly it will come back and meet with the other charge particle. If negative is revolving or if there is positive, then the size of this spiral path will increase and that will move as much distance as they can. Okay, so this is the characteristic. So earlier it was proven that when one charge particle move around the other charge particle, it loses its energy. Okay, it was that one. So this thing was not explained by Rutherford model, right? When one charge particle moves or revolves around other charged particle, the moving particle, the moving charged particle will lose their energy, will lose their energy, okay, by emitting radiation. So this is the radiation where the energy is lost. So this indicates the energy loss. And radiates, this is also called as radiates, that is radiates energy. Sometimes this term radiates is written, radiates energy. Okay, as a result, the moving charge particle will try to come closer to the other charge particle and it will fall over it if it is negative charge, and if it is positive charge it will move away from the other positive charge. Therefore the negative electron will lose energy, and the while the energy is lesser, it will move over the smaller radius and move over a smaller radius, and finally fall over the positive charge nucleus. So this was the basic law of physics. He could not explain why this electron is not falling over the proton and why this atom is stable. So thus the atom should collapse. Collapsed means they mix together and the atom itself will destroy. It's simply meant that. So this stability of atom was not explained. So thus atom is not stable. That is, so if you are asked to write a simple word, what was the drawback? The stability of atom was not explained. So the stability,
Not defined.
yes, the stability of atom or non-collapsible nature of atom. So non-collapsible nature of atom was not explained by Rutherford model. Okay, so this was the major drawback. It simply means I had already drawn this structure. When the electron is revolving, say the nucleus is this one is our nucleus. Let us consider an electron which is negative charge, which is revolving. While it will revolve around this have a tendency to lose the energy. As a result, the path will be of this shorter radius and finally it will fall. So it shall come and stuck to this nucleus, but practically it is not happening. This was not explained by Rutherford model. So this was the major limitation of Rutherford model. Okay. The other thing, nucleus and electron are held together by electrostatic force of attraction, which would lead to the fusion between them. Another thing, the second we may also write the other way. You are getting that proton is inside the nucleus. If the electron is here, there is continuously attraction. So by this way, they shall also get fused or get matched with each other. If above theory is not true, then at least this should be true. Okay. So write down the second point or second limitation. Nucleus and electrons. This nucleus means it is positive charge. Okay. And electrons means it is our negative charge. Okay, students, are held by force of attraction because they are opposite charged, which is lead to collapsing, which leads to fusion or collapsing mean the same thing. Fusion or collapsing between them. This means Again, atom not stable. Atom not stable. So even the second phenomena was, so it could not be explained by Rutherford. Rutherford model. Okay, so these were the two important limitations. First thing, according to physics, if the charged particle is moving around other charged particle, it will radiate energy and moving over the spiral path itself fall to the nucleus. But practically it was not happening. This was not explained by Rutherford. Another, even the proton, this nucleus is positive charge and this electron is negative charge, and there is a force of attraction between the opposite charge, so they shall attract each other and lastly they shall fall over each other, and the earlier size what we were calling as this much, so this size shall get reduced to this one, means the size should be fused, size should reduce after certain time, but it is also not happening. Okay, it was the second limitations. So these were the important limitations of Rutherford model, but the achievement was he proposed or he discovered the nucleus which is still followed or still it is observed. At his time only proton and electron was discovered, so there was nothing about the neutron. So third observation is also right. No any consideration of neutron. Why? As it was not discovered at that time. So this was discovered in 1932, but Rutherford carried this experiment in 1907, and in 1908 he was awarded by the Nobel Prize. So this was all about our Rutherford model. Students, here we have learned, these are very important, that this Rutherford model is nothing but it is alpha particle or bombardment of alpha particle over the thin foil, and a scattering or deviation was observed. Therefore, it is also called as, so this is also called as alpha particle scattering experiment, also called as, write the name, alpha particles scattering experiment. So whether it is asked for alpha particle scattering experiment or whether it is asked for alpha particle bombardment experiment or Rutherford model or experiment, all mean the same thing. Okay, students? So please do not forget, it is entirely new things. So I hope you will go through the videos wherever required. So this scattering experiment was carried out with the help of alpha particle. So what is alpha particle? How was this setup? So what was the purpose of each of the component in this setup? That I have also observed or I had also explained. Then what was the observation for most of the alpha particle passing as it is, some were deflected and very few were returning back even. So from that, the three important observations were given. So these are the three important observations. Students, it is very important. So based on these three important observations, the three conclusions were also given. Okay. So from this, the very first, atom have empty space, means this one. Another, the size of this nucleus or the positive charge present in the atom is in various small region. This region was later on, from the third conclusion, it was called as nucleus. Okay, so from second and third observation, he proposed the concept of nucleus, and the model was like this. The nucleus, which is very heavy and very smaller in size, at the center, electron is revolving around it. So these are the reason of electrons. So this was based on this, the model was given. The model, nucleus, nuclear size, and electron, how the electron is present in the atom, but he could not explain certain feature like why the atom is stable. So this was the major drawback. The stability of atom was not explained by Rutherford. Okay, the atom could not explain. Means why the atom is stable, means it is not decrease in size or no fusion. Why it is not fusing to the reduced size, this was not explained. At that time, there was no neutron discovery, so nothing was talk about the neutron. So students, these were the important key things regarding the Rutherford model. Okay students, if you have any doubt, then please ask to me. Students, very quickly ask to me.